Greetings to all of you. In today's session, we are going to discuss about the chemistry on the international floor. If you are preparing for any entrance exam or competitive exam in terms of international exams, in addition to this one, what JEE Advanced and JEE Mains exam for IITs and NITs, that kind of engineering stream entrance exam, it will be helpful. NEET chemistry for medical entrance examination, Telangana and Andhra Pradesh MCET exam for engineering entrance. In addition to all these, if you are aspiring for any kind of competitive exam conducted by the government, so all these cases, it will be very much helpful. Let's enter into our today's session. Name the following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. IUPAC gave certain regulations in order to name organic compounds. As per the IUPAC protocol, what will be the names of these compounds? All these are the part of what? Ethers. Ethers are well known, and whenever you are taking in your hand, what happens? Immediately it will be evaporated. That kind of compound ether will be. Let's see how to name these compounds as per the IUPAC. Okay, so here CH3O, CH3 will be there, where you can find this what O in between two alkyl, right? So simply we can represent ROR. It can be regarded as ROR, being it is methyl CH3, so that alkane name is provided as a methane as a parent chain name. And here we have CH3O, CH3. In general, we have to mention alkoxyalkane. It can be regarded as a alkoxyalkane. Okay, so in terms of this one, you can mention one of the chain can be one of the fragment can be regarded as methoxy. Second fragment can be regarded as methane. Methoxymethane is the entire name of the given compound. If you move on to compound number 2, there is a ambiguity where we have to take methoxy, where we have to take methane. Okay, so alkoxy part, which one is alkoxy part, which one is alkane part, that we have to know. In order to assign that, longest chain taken as the parent chain. Okay, so that let me mention this CH2, CH3 as a ethane chain, what we have to take as the parent chain, and this alkoxy will be the methoxy. Right, so that the name of second compound will be methoxyethane. This is the right naming of compound number 2. If you take symmetrical one, symmetrical means both the sides having same number of alkyl chains. Here you have ethyl, here also ethyl. There is no ambiguity. It is very clear. That's the reason why root chain can be taken as ethane and one of the chain can be taken as ethoxy. Right. Let me mention ethoxyethane is the IUPAC name of compound number 3. Right. So if you move on to compound number 4, where we are having one side 3 carbon chain, another side 2 carbon chain. Obviously, the 3 carbon chain will become parent chain. So that let me mention propane is the parent chain. And leftover functional group will become ethoxy. So that it will be 2-ethoxy propane. Where can you find this ethoxy? On the second carbon of this one. So 1, 2, 3. On the second carbon, you can locate this ethoxy so that it can be taken as 2-ethoxy propane as the IUPAC name of the compound number 4. This is the way we can. Alkoxy denotes what? OR. OR means wherever you are finding CH3O, CH3O, CH3, CH2O, CH3, CH2O. All these are the part of what? OR, which simply represented as alkoxy group. Fine. Let's see how can we denote this alkoxy. Right. In order to mention this alkoxy will be simply denoted with OR. OR might be OCH3 called methoxy, OCH2CH3 called ethoxy, OCH2CH2CH3 called propoxy. This is the way you can extend. This is called what? Homologation. From one chain to another chain, if only difference is CH2, that is said to be homologation. Here you can find OCH3, here you can find OCH2CH3, here you can find OCH2CH2CH3. In this manner, you can increase the chain length as per your wish, methoxy, ethoxy, and propoxy. This is the way we can pronounce them. IUPAC regulated the name as a alkoxy-alkane. Alkoxy-alkane. Longest chain can be taken as the alkane parent chain. Alkoxy will be the side chain like ethoxy, methoxy, propoxy, like this, right? Thus, by writing hyphen before the name obtained, we also write the number of carbon atoms carrying the alkoxy groups. On which carbon this alkoxy group is there, that we have to mention with the hyphen. So number is denoted with the hyphen. This is the one they are explaining clearly. Right, hyphen is required, and on which position alkoxy is there, that to be determined, that to be mentioned. Okay, so this is about what IUPAC nomenclature for which compounds? Ether compounds. Okay, so this is the problem question provided with the 4 unknown compounds. We need to assign name. So just now we gone through them. Let me repeat once again. This is said to be what? Methoxy, methane. And second is called methoxy, ethane. Third is called ethoxy, ethane. Fourth is called 2-ethoxy propane. This is the way we can mention its name as per the IUPAC protocol. So for question number 1, this will be the way to answer this, right? Move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education. Here is the table. Data is provided. The table shows some properties of 4 group 1 elements. Main group 1 elements are provided, and their melting point values, boiling point values, and atomic radius is also provided. Okay, certain gaps are there. We need to assign them. Okay, so there is a certain logic in order to fill this. We don't know exact numerals about them. Only the thing we have to remember is we have to go through their periodic properties. So if you know the periodic properties, it is obvious to mention their whatever vacancies you can locate over here, we can simply fill them, right? So what they are asking for, complete the table by predicting boiling point of rubidium. Rubidium boiling point is empty, and atomic radius of potassium. Atomic radius of potassium is also empty. You don't know anything. So you don't know anything about this one. Still, you can answer this question. How can we do that? So if you see that boiling point values from top to bottom, if you see melting point values are gradually decreasing, no? In a similar manner, boiling point values also decreases. That's the reason why whatever the value mentioned in the options in between 760 and 671, you can clearly mention that one over here. Though you don't know anything, very simple phenomenon. Here melting point values are clearly decreasing. In the similar manner, boiling point values also decreasing. That's the reason why whatever value laying in between these two numerals, you can simply put over here. Okay, very simple thing you can notice. And one more thing, atomic radius. Being it is the main group 1 elements, obvious that top to bottom size will be gradually increases. Size of the atom gradually increases. Atomic radius in nanometers also increases. That's the reason why whatever value laying in between 0.191 and 0.250, that you can put over here. Simply you can put over here so that atomic radius of potassium will come into picture, right? This is the way we can answer this. Let's see exact answer for this question. Properties of rubidium. If you see properties of rubidium, boiling point exactly mentioned as 961 Kelvin. That is required to be filled over there. 961 Kelvin to be taken. And for potassium, what they are asking for atomic radius is required. No, atomic radius is 203 nanometers. So this is the value also. It is required to be inserted over there. So these are the required answers. Exact values we are seeing. This is collected from the Google. Boiling point of rubidium taken as the 961 Kelvin, and the potassium atomic radius in the nanometers is provided as 203 nanometers, right? So this is about the answer for question number 2. Okay, boiling point of rubidium is known to you. Atomic radius of potassium is also known to you. Though you don't know, it is not possible to remember the numerals. What we have to do, Only the thing we have to do is, as we are descending, values are gradually decreasing. Whatever laying in between, you can put over there. And in case of atomic radius, whatever values are increasing in between this 0.191 and 0.250, whatever value you can observe, that you can put over here. This is the way we can answer the question number 2. Move on to question number 3. Question number 3 is collected from JEE Advanced 2022 question paper, right? The treatment of galena with HNO2 produces a gas that is. Galena is the ore of lead. Everybody aware that galena is a lead sulfide. This is called galena, and galena can be treated with what? Nitric acid. HNO3 is called what? Nitric acid. Whenever galena is treated with nitric acid, there is a release of lead in the form of Pb+2, and nitrate will be released NO3 minus. Sulfur, elemental sulfur will be deposited at the bottom. You can see the arrow downward, which indicates what? Solid sulfur. And NO denotes what? Nitric oxide. Nitric oxide is moving up. Nothing but it is a gaseous component. And either one is about water. This is the balanced equation. You can clearly see where the gaseous molecule releasing will be nitric oxide, right? So what they're asking for? Gas. So from this only you can clearly understand, among all the products liberated, they are purely asking for this nitric oxide, because this lead +2 is aquated solution. You can see ion, and nitrate is also aquated solution. Ion is aquated, that means mixed with water. Sulfur is deposited at the bottom. Only the gas evolved will be nitric oxide. NO is called what? Nitric oxide. Water remains aqueous form only. So that it is obvious to put over nitric oxide as a gas released during the reaction between galena and the nitric oxide. Now let's see the options, whatever correct regarding this nitric oxide. Nitric oxide is paramagnetic. Absolutely it is paramagnetic only because whenever any compound or any molecule is said to be paramagnetic, whenever it contains a lone pair of electrons in its outermost shell, right? And bent geometry, let's see whether bent geometry is there or not. An acidic oxide, acidic or basic, we will see. Colorless or colored compound, that also to be predicted, right? Among all, the exact answers are A and D. Remaining all are false statements only, right? The correct statements are paramagnetic and colorless. Let's see how can we here it is clearly mentioned NO is said to be paramagnetic and colorless gas. Let's see how can we explain that one. Okay, so here this is the diagrammatic representation of nitric oxide, where nitrogen atomic valency orbitals were taken and oxygen atomic orbitals were taken. Nitrogen 2s2 2p3 will be the valency shell configuration. Oxygen 2s2 2p4 will be the valency shell configuration. If you take 2s orbitals in two sides, that will put the electrons like this, and you can find bonding and sigma star orbital filling is possible. And whenever 2p orbitals, 3 electrons of nitrogen, 4 electrons of oxygen get combined, so the total of 7 electrons we need to fill. So here initially pi 2p, what we can say, pi 2p by pi 2p z orbitals got filled, followed by sigma 2px, later on pi star 2py orbital. Only 1 electron will be there because total 7 electrons to be filled. No, 2 plus 2, 4 plus 2, 6. 6 plus 1, only 7. Here you can find odd electron. That's the reason why we can notice it is paramagnetic. Paramagnetism of nitric oxide accounted for what? This unpaired electron present in this pi star orbital, right? So, and it is the kind of colorless gas. This is the way you can answer question number 3. It is a paramagnetic in nature, colorless gas it will be. It is some simply logical question. How can we say logical question? So here you have to know what is galena first. If galena is not known, it is not possible to put the chemical reaction. And though galena is known, and whenever nitric acid is treated, what products we are getting, that is also required to be known. So if we study metallurgical process thoroughly, then only we can put all the products over here in a exact balanced equation form. Then only you can understand which is a gaseous product. And in this gaseous product also we have to aware about how to draw the molecular orbital diagram. Then only it is possible to understand whether it is paramagnetic or not, whether it is colorless or not. Right? So this is the way question number 3 can be answered. A and D are the correct answers. Move on to question number 4. Question number 4 is the part of what? Magnesium, calcium, magnesium. So it is the part of second main group elements. Okay, so here certain chemical reactions are there, their products they are expecting. It is somewhat we can say simple question compared to third one. In the fourth question, chemical reactions are provided. Product to what are exactly mapping we need to introduce here. That kind of matching we need to do, list 1 with the list 2 chemical reactions. Okay, so for this the correct answer will be first one, that means hydrogen. H2O2 denotes what? Hydrogen peroxide. Hydrogen peroxide is the kind of open book model structure, no? So that hydrogen peroxide can be evolved in two reactions, Q and S. Let's see where it is located. First of all, let's solve all the chemical reactions so that we will enter into where we can get these products. Okay, after solving all the chemical reactions, we will see where these products are released. More than one reactions are able to give the same product as well. That's why we will see in a clear manner. First, we will go with the chemical reaction P. In the P chemical reaction, they are asking for magnesium bicarbonate can be reacted with calcium hydroxide. Whenever magnesium bicarbonate, calcium hydroxide are treated, there is a formation of magnesium carbonate, calcium carbonate, and water. This is the possible chemical reaction. In Q, barium oxide, sulfuric acid, when treated, barium sulfate and hydrogen peroxide will be treated, will be formed. These are the products generated. Barium oxide and sulfuric acid on treating barium sulfate and what we can say H2O2, hydrogen peroxide can be evolved. This is a Q reaction. R reaction, magnesium chloride is treated with calcium hydroxide. Magnesium hydroxide and calcium chloride will be formed. This is the way chemical equation can be written, right? Where you can see displacement. This is said to be what? Double displacement. What is meant by double displacement? Whatever ions present on this magnesium can be replaced with hydroxide on another metal, which is called double displacement. We are displacing the ions from one metal and second metal as well, so that we can say double displacement, which is also said to be metathesis reaction. Okay, simply you can put chlorides on calcium, hydroxides on magnesium. This is the way we will get the products for our reaction. S reaction is the kind where barium oxide can be treated with hydrochloric acid. Again, it is the kind of double displacement we can say, right? So in order to balance the equation, you need to put two hydrochloric acids, then only barium chloride will be formed. Two chlorides are required in order to balance the bivalent charge of barium, so that we will get barium chloride, and leftover will be hydrogen peroxide. So that here requirement is 2 moles of hydrochloric acid when introduced, so that barium chloride and what we can say hydrogen peroxide will be generated. So these are the coefficient they are putting. So what coefficients we require, that is your question. So we have to write the balanced equation over here, right? So this is the way question is chemical reaction can be solved. Move on to T, where you can find the calcium hydroxide, calcium bicarbonate. Calcium hydroxide, upon treating with calcium bicarbonate, the leftover, the required products will be calcium carbonate and along with the formation of water. This is the way we will get the equation, right? So here again, in order to balance, we need to put two coefficient for the product calcium carbonate, so that entire equation get balanced. I think water is also required in 2 moles, because here we have 2 hydrogens and here also we have 2 hydrogens, so that 2 water are required, so that equation perfectly balanced by introducing coefficient 2 moles of calcium carbonate and 2 moles of water molecule, right? This is the way T chemical equation can be solved. So individual chemical equations are given with their clear product formations. Now, let's move on to the question part. The question part, they are asking for H2O2. H2O2 is called what? Hydrogen peroxide. That hydrogen peroxide can be released in the equation Q, equation S. Equation Q, can you see hydrogen peroxide in the reaction? Barium oxide upon treating with sulfuric acid, barium sulfate and hydrogen peroxide will be formed. This is the way hydrogen peroxide can be liberated. And another, barium oxide upon treating with hydrochloric acid. Can you find any similarity? In both the cases, barium oxide is the reactant and both are acids only. One is sulfuric acid, second is hydrochloric acid. Very simple. Okay, so here the product will be barium chloride in addition to the hydrogen peroxide. QS are able to release this hydrogen peroxide, right? Move on to second option, magnesium hydroxide. In which reaction magnesium hydroxide you can locate? Magnesium chloride on treating with calcium hydroxide, the reaction is said to be double displacement, which is also called as metathesis. Around the central metal, there are set of chlorides and set of hydroxides are there. They get interchanged among themselves so that we will get magnesium hydroxide and calcium chloride. Magnesium hydroxide can be found in the reaction R. Move on to S. Barium chloride, where you can find barium chloride as the product, that is possible in S chemical reaction. Barium oxide upon treating with hydrochloric acid, you can generate barium chloride in addition to the hydrogen peroxide. This is the way you can answer S. And another one, calcium carbonate. Where can we find the calcium carbonate? In the equation P, in the equation T. In both the cases, calcium carbonate evolved as a product. It is a solid compound. Whenever magnesium bicarbonate treated with calcium hydroxide, formation of magnesium carbonate, calcium carbonate and water. You can locate calcium carbonate over here. That calcium carbonate is the product in equation P. In addition, T, calcium hydroxide, calcium bicarbonate, if treated, calcium carbonate and water will be generated. This calcium carbonate is said to be a product and required for this option number 4. So that PT are releasing calcium carbonate. This is the way we can answer question number 4. Question number 4, very if we have the certain idea about how to solve these chemical equations, how to balance the equation, how to get the expected product over here, then only it is possible to answer this kind of logical question, right? For question number 4, first option will be mapped with the Q and S. Second option will be mapped with P and R. Third option is exactly mapping with S. Fourth option P and T. This is the way we can answer. It is the kind of inorganic chemistry question. Move on to question number 5. Question number 5 is collected from Gurukulam Degree College Lecturer Entrance Examination. Let's see. The copper plus 2 metal ion which form octahedral complexes with the following ligands. Which one among the following ligand forms a less stable complex? Okay, less stable complex is required to be identified. Okay, here is the question which is collected from which area the question is coming. The question is coming from coordination chemistry. Coordination chemistry finds the large weightage in the chemistry because so many kind of complexes are there. So many complexes plays a vital role in the catalyst, and they also forms the complexes find day-to-day applications in everyday life. These complexes are very much helpful. They are colored in nature. They are optically active in nature. Magnetic properties they will possess. That's the reason why multiple applications you can find for coordination compounds, which will find the high weightage in the inorganic chemistry, right? Copper plus 2 metal ion which forms the octahedral complex. So copper plus 2 is forming octahedral complex. Generally copper able to give the square planar complex. Certain cases octahedral complex is also possible. You can notice John Teller distortion in these complexes, right? And whenever these copper metal is binding with the ligand, and whatever ligands provided, all are bidentate ligands only. Whenever any metal binding with the bidentate ligand, there is a formation of chelation. chelated compound will be generated. We will see what is meant by chelation and how it impacts its stability. Okay, so in that case, in that chelation property, ethylene diamine was taken, propylene diamine will be taken, butylene diamine, methyl ethylene diamine. Among all, least stable complex we need to notice. Least stable complex will be butylene diamine, right? So for question number 5, option number 3 is the correct answer. We will see how can we explain this one. First of all, from the Wikipedia, we collected what is meant by chelation. Chelation is a type of bonding ions or molecule with the metal. Okay, chelation is the complexation of ions or molecules with the metal, and that involves the formation of a cyclic ring. A ring type of structure will be generated over there. Okay, whenever coordination bonds between the polydentate ligand, this is more important. The polydentate ligand denotes what? Any ligand which is having more than one kind of functional groups releasing electrons to the central metal. Okay, the set of ligands are having more than one functional group to release the electron pairs to the central metal, then it is called a polydentate. And this is more extensively explained by the Liber text, stability of metal complexes by chelation process. Okay, so according to this one, they are explaining by taking the example ethylene diamine with a nickel plus 2 complex. This is the kind of simplest example. You can see ethylene diamine is chelating with the nickel plus 2, where you can see NH2 is the one electron pair donor to the central metal, and another set will be this NH2 is releasing another lone pair of electrons to the central metal, so that they more than one functional group releasing electrons, there is a formation of a ring type of structure. This is said to be a chelation. This kind of chelation is possible. It is clearly explained with this one. Okay, this is about chelation. Now what we have to do, we have to compare the chelation in these 4 options. What they are asking for: least stable complex, least stable chelating complex, we need to identify. Among all, ethylene diamine, if you are taking ethylene diamine, this is the way you can locate. Arrow is indicated like this. NH2 to metal, the kind of bond is located, and it used to give the ring type of structure. Ethylene means 2 carbons, diamine means 2 amines, NH2 will be there. This is the way ethylene diamine complexation with the metal is possible. Always, when compared to the monodentate ligands, chelation complexes are more stable because they are able to form a symmetrical ring. No, whenever symmetrical ring is there, even by pulling, that can't be removed, so that we can say the chelated complexes are highly stable. Okay, but within the chelation, we are going to compare with the different kind of ligands. Okay, ethylene diamine ligand chelation will be represented over here. Propylene diamine, if chelated like this. Okay, propylene diamine, here carbon chain length somewhat increased. If you see ethylene, we have 2 carbons. Propylene, you can increase 1 carbon, so that chain ring structure got expanded. Ring structure got expanded, so that stability slightly lowered, because this is looking more symmetrical without any repulsions, and it is highly favorable kind of thing. Okay, whenever propylene is there, what happens? That will become a puckered one. It is not a straight symmetrical, rather it will be a puckered one. This kind of structure will give somewhat less stability towards the complexation, right? Move on to another butylene. Butylene means what? How many? 4 carbons will be there. CH2, 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 and NH2 will be there, 2 functional groups. So that this will be the kind of chelation. If you observe this one, as we are increasing the number of carbons, chain ring expansion is possible, and that is not laying in a symmetrical manner, so that this will become more hindered kind of thing, and we can say it is more unstable. Butylene diamine, if you see, ring got expanded largely, so that it will be more unstable for the complexation with the metal. And another one is given, that is methyl substitution. on this ethylene diamine, same first one only. Only the difference is we are putting a methyl over here. This is said to be methyl ethylene diamine. And whenever it is complexed with this metal, here stability still rises. When compared to ethylene diamine, we can say this is more stable in nature. What could be the reason? Because methyl is having plus I inductive effect, so that it will release the electrons into the ring, and it will increase the electron density on amine, so that chelation is more strong, so that stability will still increased. Anyway, the correct answer will be highly stable copper plus 2 complexes will be, sorry, least stable copper plus 2 complexes will be butylene diamine. For question number 5, option 3 will be the correct answer. Least stable, they are expecting least stable will be butylene diamine. Move on to the last question of the session. Sixth question, what is the correct order of their stability for the given metal ions, right? So these many metal ions are provided, and stability towards formation of complexes, how they are becoming stable. Okay, so here sodium is there, calcium is there, yttrium is there, thorium is there. If these many are present, what will be the correct order we have to notice? In order to explain this one, there is a relation between charge to size. Charge to size relation will be there. We can say charge to size ratio as well, right? So here there is a information regarding this charge on the central metal, and which is affecting the stability of the complex. So the Lal Institute, from that I collected this information. The stability of transition metal complexes with the same ligands and a similar coordinative environment, but increases with increasing the charge on the central metal. Okay, so these many set of central metals are provided, so that, so same coordination sphere is there, same ligands are there, but the stability of the metal will be more whenever charge acquired will be larger. So that is given in this statement. Okay, if you are seeing all these, what happens? As the charge increases, the size will be decreased, which is clearly explained with these footballs, right? Sodium is sodium monopositive in nature, so that you can locate it as a larger globe. And calcium is a dipositive ion. Calcium plus 2 will be there. It is said to be a dipositive, so comparatively size got concised, right? And yttrium plus 3, yttrium is the metal which is acquiring plus 3 charge. That's the reason why comparatively its a charge, its lobe size is still, its a sphere size is still smaller, right? And the tiniest one is a titanium plus 4. You can locate it as the very tiniest. Whatever the tiniest metal is there, that able to give the highly stable complex formation. You can clearly see stable complex formation is possible with the tiniest larger charge species, right? That's the reason why titanium or thorium, here they are saying about thorium, but here charge is plus 4, no, so that you can mention it as a thorium plus 4 as well, right? So greater the charge, greater will be the stability, smaller will be the size. This is the way you can clearly answer based on its charge. Okay, so there are certain kind of factors which affecting the stability of complexes in the coordination compounds. Nature of metal, in that nature of metal, in which main group it is located, that also matters. What charge they are acquiring also matters. What will be the size of that one also matters. How electropositive it will be, that also matters. In this manner, so many factors will affect the stability of coordination complexes. Sodium is larger, calcium plus 2 and yttrium plus 3, thorium plus 4. Larger the charge, greater will be the stability. That's the reason why we arranged in the increasing order of their charge. This will be the correct answer for question number 6. For question number 6, option number 2 will be the correct answer. By this, we entirely completed the session. Detailed explanation is provided for various questions which are collected from various entrance examinations. So that I hope the session will be very much informative. And I'm sincerely requesting you to like the channel and comment which part is really interesting for you. and where you got the real information regarding, and share the content with the aspirants who are seriously preparing for any kind of entrance or competitive exams as well, and subscribe the channel in order to receive more such kind of updates in the near future. Thank you very much for your patient listening. Thank you one and all.